In this lesson, you will learn about the composition of functions. The composition of functions happens when you plug in one function into the other. It is symbolized by a little o, just like you see here. The order of how it's written is really important. So for this first example here, or not the example, but the formula, it says f circle g of x. What that means is you're going to take the last function, which is g, and you're going to plug in into f. So the whole function of g is going to replace the variable in f, and then you simplify. The same way here, we have g circle f. You're going to take f and plug it into g. So you always take what the last function is and plug it into the first. Let's go ahead and do some examples. So number one, we're given a function f of function g. You are looking for f circle g. What that means is you are going to take the function g, which equals this, and g replaces f. So it's going to replace the x variable right here. So we just need to write that out. We have f circle g. You can write f circle g equals if you want to. You don't have to. You just need to know how to plug it in. So f, you go to your f, which just says -4, open parentheses, plug in your g, which is 2x minus 7, and then write the rest of f out, which is plus 9. So hopefully you see what's happening here. This function just replaced the x. This is where the x was in f. After you do that, this is the hardest part right here. After you do that, you just need to simplify. -4 times 2x is -8x. -4 times -7 is a positive 28, excuse me. And then drop the 9. These two are like terms, so -8x plus 37. So f circle g will equal -8x plus 37. Let's do another example. So this one says f needs to go into g because f is at the end. So I'm taking my f and I'm replacing my variable in g. If you have more than one variable, you're going to replace both. Then we simplify. This one's going to be a long one, so I'm not going to rewrite this. So this will equal, so f is going into g, so I'm going to my g, and that's what I'm going to start writing out. You start writing out this first function. So here I have 4. Every time you see an x, go back to the other function and substitute. It's squared, so I'm making it squared. Then minus, since it's a minus, I'm going to go ahead and put that in parentheses. 2x, because remember we have to distribute our negative, minus 7, and then drop the 10. Now we just have algebra. Okay, order of operations says we do exponents first. You cannot distribute this when you have an exponent. So I have 4. I'm going to write that out twice because it's a binomial. Here I can go ahead and distribute the negative. Remember, when you're distributing a negative, change the sign, change that sign, change that sign. So now we have minus 2x plus 7 plus 10. I have to actually go ahead and FOIL all of this out. So let me draw a line here so we don't get mixed up. Okay, I have my 4 and then FOIL. 2x times 2x is 4x squared. 2x times -7 is -14x. -7 times 2x is -14x. -7 times -7 is a positive 49. Okay. Then we have minus 2x. Let me go ahead and add these. 7 plus 10 is 17. Now I'm going to combine these like terms. So I'm going to bring down my 4. I have 4x squared minus 28x plus 49 minus 2x plus 17. Then finally, I'm going to distribute this 4. 4 times 4 is 16x squared. 4 times -28. I'm going to do that on my calculator to get -112x. 4 times 49 is 196. So plus 196. Bring these down. This one was kind of a long one. Now I'm going to combine my like terms. Okay, let me underline them. I have negative 112x minus 2x, and then I have this one and this one. Uh-oh, did not mean to do that. So negative 112 minus 2 is negative 114x. 196 plus 17 is 213. And that's as far as you can go. You don't need to factor or anything. Don't get that confused. You just plug in and then you simplify. Let's do another one. Okay, this one says f into g. So here's my f, because it's at the end, and that's going to replace that. So I'm starting from my g. I have 5, and then I have open parentheses, plug in that f, which is 2x minus 5 with the square root. That is squared minus 3. Okay, I need to simplify this. A square and a square root are inverse operations, therefore they will cancel. So I have 5, 2x minus 5 minus 3, distribute. 5 times 2x is 10x. 5 times negative 5 is negative 25, then minus 3. So we get 10x minus 28. So that's how you work out composition of functions. The key here is take the last function, replace all the variables in the first function, and simplify. And that's it.